my channel, The Machining Maestro. Today I'm going to explain you the plane turning programming by using Siemens Sinumerik controller. So before going for the plane turning, we should know what is plane turning. It is also called the straight turning. Is a fundamental lathe operation that uses a cutting tool to remove excess material from a cylindrical workpiece, reducing its diameter to a specified dimension while maintaining a uniform diameter along its entire length. So from this model, you can get some idea that the red highlighted portion is going to be removed, and hence the diameter of the raw material will be reduced to some length. And when you come to the orthogonal view of this model, this red hashing portion is the amount of material going to be removed. So our goal is that the raw material is 40 diameter, and we will maintain it to diameter 30, and that this diameter 30 will be maintained up to 20 length. Okay, so this is the raw material length. Okay, so next we will see the tool what we have used over here. So this is the tool data. So the holder is used over here is PCLNR 2525 M12 with a fixation of insert CNMG 120408. So regarding the tool details, I'm explaining you in my next slide. It is all about your tool data. This is the tool, and the black portion is the holder and the yellow portion is the insert. The holder name is PCLNR 2525 M12 and the insert name is CNMG 120408, and this is called the ISO designation of the holder, and this is the ISO designation of the insert. This designation has some meaning. So the meaning I have briefed you in the left side, and here is the meaning of this designation available here. The meaning of P is the clamping type, which is P type clamping, and there are already various kind of clamping. P is one of them, and the C is the insert shape or insert angle, which is 80 degree. The angle which is producing over here is 80 degree. The tool holder type or tool holder angle, the angle is produced between this surface and this surface is 95 degree. The insert side clearance angle is 0, which represents N. N represents the side clearance angle is 0 degree. The angle is produced over here is 0 degree, and R is representing the right hand cutting tool, and 25 is the shank height, and 25 is the shank width, and M is the total tool length, and toll is the insert cutting edge length. The length of this yellow portion's wall, which is the cutting edge, the length of the cutting edge is 12, which is in So this is all about the ISO designation of the holder. Actually, there are many kind of holders and of their many kind of designations, many kind of designation meanings, which I will explain you in my coming videos, where I will take the example of many different kind of tools and their ISO designations, and we will discuss one by one over there. So it is just a quick briefing for you to understand this tool, because this tool we are going to create in our machine controller, so that this tool can be used in the program and you can check the simulation properly. And now come to the insert data. The designation says C is the insert shape or insert angle, which is 80 degree. N is the insert side clearance angle, which is 0 degree. The clearance angle is produced over here, which is 0 degree. M is the grade of tolerance or class of tolerance. There are many grade and class of tolerance. M is one of them. And G is the fixing type or chip breaking type. The inserts are always designed with some chip breaking formula or chip breaking designs or fixing designs. So there are many kind of such designs. So G is one of them. and 12 is the cutting edge length. 12 is the cutting edge length in mm. The cutting edge length is the length between the two adjacent sides of the insert, which is 12. 4 mm is the thickness of the insert, and 0 it is the corner radius or nose radius, which is in mm but 0.8 mm, not 8 mm, it's 0.8 mm. So you see the CL12, C1208, these are I have highlighted in red color letter. So these are the information which we require to create the tool in our machine controller. So let's go and create the tool over there. Thank you. Now this is your machine interface. We are going to create our new tool. For creating new tool, you go to offset, and in this window you see there are already many tools in your tool list, and they are situated in different magazine locations. You can see from here. So if you want to create a new tool, actually there is two type of method. Maybe you can delete this tool, or maybe you can unload that tool, and at that position you create your new tool, or else you can create your tool at any empty position. But if your turret is having 8 number of tool stations, then you can use the location up to 8 only. If your turret is having capacity can carry up to 12 number tools, so you can use your location up to 12. So meaning in my case, I'm going to create my tool at location number 1 for example. So that's why I will delete this tool, or else I will unload this tool. So for unloading this tool, you click unload. So while unloading, the tool is getting placed at the bottom of the tool list. So later you can load it to any position or any location position you want. But for deleting any tool, you just click here and press delete. So after pressing delete and clicking OK, the tool is getting disappeared completely. The tool is not available for you anymore. So these are the two cases. So if you want to load this one, you click here and press load. It is asking in which location you want. So you can give 9 to anything. So I'm giving 9 number, then or maybe 10 number. So you see that in 10 number there is no tool available. You press OK. The tool is now at location number 10. So in this way you can load unload your tool. Loading is a good option because later you can use that tool, and the parameters will remain same. All you need to change your offsets only. Offset meaning the references only. So at the position number 1, location 1, I'm going to create my tool. For creating the tool, you click on new tool, then choose your tool. Our tool is the roughing tool because PCLNR is a roughing tool, and out of these cutting edge positions, you select the first one, then press OK. Then give your tool name. I'm giving PCLNR 2525 M tool. Then press input. So after pressing input, the sister tool and the cutting edge position, these two are become one and one, because there is no such tool kind of tool is available in your tool list. If you find any PCLNR 2525 M tool, same identical tool over here, the sister tool become two. But since only one tool is over here, that's why the sister tool is only one. And D is the cutting edge position, cutting edge number or cutting edge position, that we will discuss something later. All about this tool list creation and detail tooling part, we will discuss something in my later coming videos. So there I will explain you everything in detail, but here I am giving you just for giving you such some idea, just for a example, because without creating your tool you cannot check your simulation in your machine, or else without creating the tool you cannot run your program. So the parameters are really really important. So I'm showing you how to store the parameters here. So the sister tool gone, the cutting is gone. Length x, length z. Length x is the distance between of your tool to the diameter of the workpiece. So when you take the references, when you take the offsets, that time the values are automatically getting stored over here. And in case of z also, it is the distance between the workpiece face to the tool, to the tool. So so these two are something you will get, or it will be automatically restored when you take the offset. So since we are not doing any practical over here, I'm just putting some random values like minus 200 and minus 300. Okay. So in the radius part, that is something we got to know from my previous slide, where the nose radius I have told you it's 0.8. So you write down 0.8, then press input. Then this is the cutting direction. So out of these four, you choose this one. Okay, if you want to look for the option, then you go here and press select. So out of these these four options, you select this one, then press input. And this is the column where it is asking for the holder angle. The holder angle I have already told you, that is 95. Then write down 95, then press input. Then the next column, it is asking for the insert angle. Insert angle is also 80 degree here, so you write down 80 and press input. Then it is asking for the plunger length. Length is nothing but the cutting edge length. So cutting edge length you keep 12, because in our tool the cutting edge length is 12. So press input. Then it is asking for the spindle rotation, but this is not a this is not a milling machine, or this is not a ton mill. So that's why the spindle option, meaning doesn't matter. So keep it as it is, and go for the next option. Then it is asking for the coolant, and 2 is the dedicated coolant. So coolant is also, even though you click it on, you have to write the um, coolant on program in your full program. So if you want to turn it on and turn it off, that is up to you. And similarly, the coolant number 2 is something that if you turning it on, then if you have some dedicated to coolant supply option, then that will be turned on. So from here to here, like from this length z, radius, the cutting direction, holder angle, insert angle, and the insert cutting edge. These are something the really really important parameters. And length x, length z is something are getting stored automatically when you take the offsets or the references. So radius and cutting edge direction, holder angle, insert angle, and the cutting edge length, that you need to get the data from your tool and put it here, so that your simulation will be very proper for you, and you can visualize your mistakes or visualize your proper machining process in the simulation. So next we are going to show you how to create the program. So to create the program, go to program manager. So out of these three directory, you choose part programs and click on this plus icon. You see the facing program is here. In my last video, this program was created. So here you want to create a new program. Press on new, give the name plain turning, use capital PLAINTURNING, plain turning, then click on OK. So the program template got appeared in front of you. Here you need to put your required G codes, M codes, and the cycles. So the first thing we always do, like creating of the workpiece. So press on various, then click on blank. Choose your blank type, which is always cylinder. XA is nothing but your workpiece diameter, which is 40 mm, and ZA is the starting length of your Z, and since this is your datum position, Z is always 0. Zi is the total length of your workpiece, which is like minus 60. Why minus 60? As for the drawing, so minus 60 is given because your zi is the value which is in the negative side of the datum position. This is the positive side, this is the negative side. So zi is the total length of your raw material, which is 60. So I'm giving minus 60 and keep this absolute and give the value minus. Okay, now go to the ZB position. ZB is the length, amount of length you are keeping for the machining. Since we are doing the plane turning operation up to 20 length, so you keep a value which is more than 20 to avoid the crashing of tool with the chalk or the jaw. So ZB I'm keeping minus 30, which is all okay, or else you can keep minus 40. So minus 40 mean minus 40, then press input. It means total length is 60 the chalk is holding 20 and 40 is outside for the machining. Then press accept. After that, press input, then write down the G codes which are available for the pre-operation commands. The first one is Z90, activating the absolute mode. Then you write down Z71, activating the metric or mode. Then write down Z95. Z95 is your feed in for revolution. Then you write down Z64. Z64 is nothing but the continuous path control mode, where the machine attempts to maintain a constant velocity across blank transitions. Then you write down the homing program T0 D0 Z0 X0 G0 Z0. So T0 D0 is the tool cancel and cutting edge cancel. Then G0 X0 meaning sending our X to homing position rapidly, sending our Z to the homing position rapidly. Okay. Uh, for more details and more detailed briefing, you can check my facing program where I have explained you with details over there. So you check that program. So next we are calling my tool. So press on edit, then select tool, then choose this tool, then press OK. So this tool I'm selecting over here because this is our tool which is going to do the machining. And after that, press input, then you write down the spindle program M3 S800. M3 is the spindle rotation clockwise and S800 is the RPM. Okay, then you write down Z0 Z2.0, then write down Z0 X42.0, meaning I'm calling my tool to the safety height in Z and safety height in X. Since the diameter is 40, the safety height will be 42 and the starting length of Z is 0, then the safety distance will be 2.0. Then you turn on your coolant, which is M7. Then you create your program, create your cycle, click on turning, click on stock removal, then choose the safety height value, which is 1 over here. You write down anything like 2 also you can write down 2, then press input. Feed, it is asking for the feed rate, you give it 0.2 or anything you wish, 0.2, then press input. Then machining, it is asking for what kind of machine you want to do. So there are two options, the single inverter triangle is roughing and the triple inverter triangle is finishing. So we are going for the roughing, then press go here, click here, then it automatically gets selected. So for the positioning of the machining also you choose the external one, and if you want to look for the options you click here. Then already external operation, internal operation, external internal backside operation and external backside also available over there. So you choose here the first one. then press input, then it is then this is the type of machining you want to do. So here you select by clicking this button, and this is there are two options available. You click on longitudinal, because longitudinal, when you are selecting longitudinal, the tool travels uh, across the length. When you choose the face, the tool travels across the face of the workpiece. Okay, so when you are selecting this, press input, then x0 is nothing but your diameter of your workpiece, which is 40 input. Then z0 is the reference position of the Z. So at this datum position, you see this marked position says here Z is 0 and X is the diameter. So Z diameter of 40. So here the Z value is 0 and diameter is 40, which is nothing but the X0 and Z0. So Z0 I am keeping 0, then press input. Then x1 is nothing but is the diameter you want to maintain after maintain through the plane turning process. So the diameter you want to maintain is the 30 mm as per our drawing. So write down 30.0, then press input. Then z is the length, up to what length you want to maintain your uh, diameter of 30, which is as per drawing is minus 20. Why minus 20? Because the z value we want to maintain is in negative direction of the datum, so that's why minus 20. Then press input. Then d is the nothing but the incremental depth of cut, meaning meaning how many passes. So a cycle is consist of several passes, right? So in one pass it will take 0.2, then in another pass it will take again 0.2, which is total 0.4, then again 0.2, again 0.2, like that. So if since we are maintaining from 40 to 30, if I'm giving here 1 mm, no, 1 mm meaning automatically it will take depth 1 mm 1 mm, like that. And also one thing you notice here, when you provide the d is 1, so that time it is taking the depth radially, it means diametrically it is removing 2 mm material. So if the machining is getting started from diameter 40, then with the incremental depth of cut with the incremental depth of cut 1, at first cut it will maintain to 38, in second cut it will maintain to 36, then in the third cut it will maintain to 34, then 32, then 30. So that you should keep in your mind based on your tool strength and your capacity of the machine. So I am giving here 0.2. Okay, so 0.2 meaning in one pass it will remove 0.4 mm material from the periphery of the workpiece. So ux is nothing but the allowances, how much you want to keep at the diameter for the finishing operation. So I am giving 0.1. So uz is something how much allowances you want to keep at the uh, wall of the workpiece, which is 0. I'm giving 0.1. Okay, so what is ux and uz? When you keep ux 0.1, so instead of maintaining 40, sorry, instead of maintaining it 30, it will maintain 30.1. So 0.1 mm will be remained for the finishing operation when you choose finishing from here and run the program. So uz is something 0.1, as I told you in my facing program. When you keep uz value at the wall, so instead of 20 mm, it will maintain 19.9. So the zero point 0.1 will be removed in the facing cycle when you run the facing cycle. Okay, so this is all about the parameters of your cycle. Then press accept. Then after that, you write your post operation commands, which is Z0Z2.0, pulling out my tool to the safety position by writing Z0Z2.0. Then you write down spindle off command, which is M5. Then you write down coolant off command, which is M9. Then you write down the homing program T0 D0. then Z0 X0, then Z0 Z0, T0 D0 G0 X0 G0 Z0. These three line represents the homing of the tool. Then after that you write M30 to end your program. So M30 is um, required to be written in every program end. Okay, so this is all about your program. Now we will go to check out simulation. So click on simulation. So in simulation, from 3D view, after clicking 3D view, you can see the tool will approach towards your workpiece, and it will do the plane turning. See, from this video you can visualize the how plane turning operation is happening. Okay, so this is a plane turning operation, and from this detail command you can do the required zoom in, zoom out, and if you want to see the side view also, you can see from here. And see the insert style and everything. That is what, after providing the data to your tool in the tool list, uh, this is the insert, this is the geometry which is produced. Okay, so this is all about the simulation, and these are the passes. In one pass it is taking 0 0.2 0.2 like that, and the diameter is diameter from 40 to 30 it has maintained. So also from the side view you can get some brief knowledge about that key. See, this is a 0 position, this is the 40 position, this is a 20 position. So this position meaning the 30 it is maintaining, and from here to here is minus 20, meaning it is maintaining up to 20. So not 20, not 30, it is actually maintaining 30.1 and 19.9, because we have given allowances up to 0.1, which we will remove in the finishing cycle. And the finishing cycle is something we will discuss later. I will tell you the finishing cycle. So this is all about your plane turning operation. If you want to do this operation, execute this operation, then press execute. Then the program is automatically coming to the machine interface, and automatically the auto mode gets activated. Now press cycle start if your offsets are okay. If your tooling has done, and your chalk clamping of workpiece is done, then you press cycle start, and you you will see the machining process. Okay, so thank you very much for stay tuned, and uh, let's bring new videos in my next chapter. I will be bringing new videos where you can get to know many other CNC lathe operations and their programmings. Thank you very much.